Okay, so the next topic which you're going to see is the selection of control valves. So as we have seen in the previous slides, we have different types of actuators, we have different types of valve trims, different materials. So how we are going to decide which is the best control valve for an application, right? So the first crucial step in control valve selection is the process requirement, right? So which type of fluid you are going to measure, whether it is a corrosive fluid or it is a non-corrosive fluid, or whether the fluid contains any dust particles or slurry materials within the flow, right? So this is the type of fluid, and then what is the pressure, what is the working pressure which you are going to apply, right? So what will be the minimum pressure, what will be the maximum pressure, and what is the minimum flow rate which we need to regulate, and what is the maximum flow rate, and what is the allowable pressure drop. So all these process parameters are to be considered at the first. Now, based on this process requirement, we are going to select the type of valve, right? So which type of valve, whether it is a fail to open or fail to close. So which control action this valve is going to perform when there is an emergency. So that is the type of control valve. And then the actuator type. So based upon the pressure and flow, what is the type of actuator we are going to use? So what is the maximum load which is going to be given to the actuator? So this actuator can be either a pneumatic type, electric type, or hydraulic type actuators, right? And then once we decide the actuator, then we will select the valve trim. So what is the minimum flow rate, maximum flow rate, as well as the pressure drop. So based upon the flow characteristics which we want to achieve, we are going to select the valve trim. So as we have seen earlier, we have three different types, right? So one is a linear, another one is equal percentage, and quick opening type characteristics, inherent characteristics, right? So these inherent characteristics, they are measured for a constant pressure drop, right? Whereas while it is applied in the process parameter or in the field, they are called as installed characteristics, because if you see there, the pressure drop won't be constant, it will be changing, right? So that is the installed characteristics. So based upon the characteristics which flow which we want to achieve, we are going to select the valve trim, right? So either it can be a globe valve, either it can be a diaphragm type valve, a butterfly valve, or a ball valve. Right? And finally, the accessories which are required for the type of control which we have chosen, right? Whether we need a solenoid valve, or we need an I to P converter, air filter regulators, what are the different accessories, a pressure gauge for visualization. So all these things are given the least priority. That is the last step in the control valve selection. So next, so we have covered what are the different types of actuators, valve trims, and the characteristics, right? And how we select the control valve. So next we are going to see what are the maintenance which are required. That is the periodic maintenance. So we have three different types of maintenance. So preventive, periodic, and breakdown maintenance. So preventive is what are the maintenance schedules which we are going to take, and the periodic measurement is what are the measurement, maintenance which are scheduled weekly or monthly in order to ensure that the control operates smoothly. And breakdown maintenance is, so if the controller has failed, what are the maintenance activities that we have to undergo. So in case of a periodic maintenance, the first thing is regular inspection. So daily a technician has to inspect for, if there is any leakages from the gland packings, if there is any visual wear and damage, and whether the valve stem is moving properly or freely. So these are the regular visual inspections. And then regular cleaning and lubrications, right? So as the control valve is a moving device, we have to periodically clean and lubricate it. So if it is present in harsh environments or in a dusty environments, the dust is going to accumulate in the valve stem and the gland packing, right? So that will create a stiction. So in order to avoid this, we have to frequently clean and lubricate the moving parts of the control valve. And the third one is calibration, right? So for each percentage of input, we have expect a certain range of stem travel. So we have to check whether the stem travel is achieved for the given input, right? So this is done through periodic calibration, right? So we have to calibrate the actuator as well as the positioner to ensure that the valve accurately operates, right? And finally, keep records of inspection, maintenance and repairs. Like you have to enter all these maintenance in the logbook such that we can understand what are the previous steps we have taken in the control valve. So this is with respect to the periodic maintenance of control valves. And next we'll see what are the common causes for failure of control valve. So since it is a mechanical device, it is going to get weird, right? Either the valve trim as well as the stem, which is exposed to the atmosphere. The valve trim is exposed to the process pressure as well as the conditions. So it is going to eventually wear out. So this wear and tear on moving parts like the stem, seat or plug are some of the common causes of failure. Right? And the next one is the seal failure. Right? So we have packings in the valve body, right, to ensure that the process fluid does not leak out. So this leaks in the valve body and the leakage in the seats. So if there is a cavitation or pitting or slurry materials, getting hit on the valve plug and seat, it will cause damage to the seats. Right? So due to this damage, there will be a leakage present, right? So this leakage in the valve body, seat or gland packings, these also contribute to the control valve failures, right? And then clogging. As I said, if it is for slurry applications, the dust particles or the solid particles, it is going to get accumulated in the valve trim, right? So this accumulation or clogging of debris will obstruct the flow path. So we may not get the desired flow rate as per the control valve movement. And finally, actuator malfunction. So if the actuator diaphragm is damaged, it may lead to inaccurate or improper responding to the control signals from the controller, right? The positioner will give the output. So for the corresponding output, the valve may not move to the desired position, right? So these are some of the common causes of control valve